Okay, thank you guys for coming out. This is Derby Pie. I guess speaker or Randy usually does the intros.
Yeah, we usually just go around the horn, let everybody introduce themselves.
Yes. So name, what do you do?
Your interest in Python.
Yeah, there we go. So my name's Wes. I do a few things. I do some consulting. I work with Level 12. I help with Code Louisville and Tech Talks. And right now I have this ML fever. So yeah, that's me. Do you want to go just this row?
Yeah, I'm Andy. I do data analytics at Humana Government right now. I use a lot of SAS, but we're switching to Python and R, so just kind of beginning to learn that stuff. So.
My name is Brandon Banks, and I work at Generation Tux, and we use Python for a bunch of different things. We do machine learning, and then just for some of our web services as well.
I'm Colin, and I pair program with Brandon all day. I'm doing the same things.
I'm Brandon, going through Code Louisville's front-end dev course right now. I've got a little bit of experience with Python and just had to pursue that there.
Good name.
I'm Keras. I'm unemployed currently. I mostly do data visualizations with Python.
I'm Keras. I work as a research engineer at U of L, and I'm more of an entry level at Python, but I pretty much use it whenever I can.
My name's Paul Klein, and I'm in transition too. I worked for 6 years at the U of L School of Medicine, and I used Python there to do some data manipulation and analysis.
My name is Frank, and I'm currently learning Python.
I'm Josh. I'm a network engineer, and I've been writing in Python for about 1.5 years, and kind of, I don't know, automated my entire job, and my boss found out. So now he's seeing if I can automate that for half the world. So yeah, I'm seeing if this. It's nice to see other people programming Python. Just I didn't know there were so many, and it's good to find a group. So.
In 2017, it's #1 now.
Really?
So. Yeah.
I'm John. I sort of retired, but I like to play. And I just started using a microcontroller called ESP32, and there was MicroPython for it. So I've been just starting to play that a little bit. And I've done a little bit of Python on Linux, but I'm mostly interested in embedded controllers.
I'm Gil. My company retired me last year. I found myself in transition. I'm going to Code Louisville. Actually, was my mentor, so just picking it up, have interest in data analytics, see where it goes.
I'm Jerry. I'm a sysadmin. I switched from using Bash to mostly Python as my preferred language to maintain my systems and handle systems. I've been recently just playing a little bit more with Flask and SQL Alchemy. So I know TensorFlow and machine learning is kind of a hot topic right now. So good learn.
I'm Matt, work at Humana. I use Python a little bit in my job, but I've mainly been learning it on the side. So.
My name is Serena. I'm in 7th grade. I don't work in the and I'm just learning Python.
Hey, I'm Joseph. I usually program robotic systems at work. Come across Python about a year ago. You know, you can make your own Nintendo and all that stuff. So I'm real good at using everybody else's code. But that's it.
That's what everybody
does. Yeah, but I want to get a little farther than that. And I got a son, he's in it, and my daughter. So we got the Python books. You know, she started from scratch. So that was a whole lot of fun for her. Anyway, just come here and check it out.
Well, I've been in the Python since the 90s. I've chosen it as a language of choice and fooling around with it, time to time. That's about it. I'm retired.
And we have a few people who just came in.
Hi, I'm Dan. I moved to Louisville about a month and a half ago. I'm working in, I'm a software implementation consultant, and we do work with Visual Basic and .NET usually, and some SQL thrown in. I took a couple classes where I used some Python in college, had like a little side project, nothing really complex. I just wanted to learn more.
Welcome to Louisville.
Thanks.
I'm Amy. I work for a site called Tech Republic, and a couple of my coworkers have been writing a bit about Python lately. So what is this? And it looked kind of cool. So I learned about this much so far, but I wanted to come see what people are actually doing with it. So.
Cool. Thank you for coming.
Alright, so my name's Alex Haynes. I currently am a professional developer with an ad agency here in Louisville. On the side, I'm founding a community lobbying startup, and one of our side projects with that is analyzing Russian bots on Reddit. And this is extremely pertinent because 2 weeks ago I just started to teach myself machine learning, and my co-founder already has a master's degree, so I'm getting up to speed. And yeah. So, I'm here.
Cool. Thanks for coming.
I'm Nate Harmon. I work for Level 12. We're the sponsors of Derby Pie. I heard somebody say they're unemployed. We are hiring right now. You go to level12.io/careers, I believe it is. I've been working with Python for a few years now. We build mostly web applications using Flask. We have some Django. And then most of my time is actually spent. We have a client that uses a Java application that does business analytics called Tahoe, and we've built some data pipelines around that using Python. So that's what I do.
Cool. Well, let's get started, guys. Thank you so much for introducing yourselves. And wanted to put this out there, and I'll leave this for a little bit. So I have the slides, and I have the Python notebook. It's case sensitive, but if you want to follow along, you're more than welcome to do so. And then I might make some changes to the notebook tonight. It was kind of last minute. But yeah, so there's a Git repo on there, and you can see the README. And then the big thing is on the README, it's about installing Anaconda and kind of getting your environment set up to actually do the code. So I'll leave this up for a little bit longer. Okay, so how's it going? You want to introduce yourself with your name and what you do, and what are you doing with Python, I guess?
Hi, I'm Jacqueline. I'm an assistant and I'm an alcoholic. No, I am a graphic designer by trade. I'm in Code Global, and I'm trying to wrap my head around Python. Still, I'm in like my 4th week. Still, but sticking with it. So teach me.
Thank you for coming.
Thank you.
Cool. So before we begin, raise your hand if you know or you think you know what machine learning is. Show of hands. Cool. All right. A few of you. Okay. So who has worked on a machine learning project before? Raise your hand. Okay. A couple of you guys. And then who thinks they know the math behind ML? Okay. So when I screw up, I'm going to make sure I ask the 3 of you. And you guys can correct me. So, machine learning is such broad and huge. Like when I think of someone doing a talk on intro to machine learning, I think someone's doing a talk on intro to computer science. It's kind of hard to encapsulate it in an hour. So I spent many a night trying to figure out exactly what level of depth to go in certain areas. So hopefully I do a good job. So let me know. Oh, and then also, I don't necessarily do a Q&A afterwards. I more like to just take interruptions as I'm talking. So questions, comments, concerns. this talk sucks, you know, that kind of thing. So I like it to be more of a discussion, and we're just kind of talking through the concepts rather than just a lecture and you guys are listening. So, all right. I hope that you guys understand machine learning as a whole. My opinion on the two big concepts, that once you get it down, it kind of clicks and there's a light bulb. So that's going to be cost functions and gradient descent. I feel like if you guys get those two tonight, then you can be rocking and rolling. So we'll see some Hello World code with a very common data set, and then hopefully get you start thinking about your own little fun projects to do. So to do that, I'll just kind of do an overview. I have an acronym called PELP, and we'll go over that. So, and then like I said, error functions, gradient descent. There's all this hype about deep learning. Is it machine learning? Is it completely different? We'll talk about that, and then my Hello World demo. Tony?
Yeah. So
how's it going? If you want to introduce yourself and what you do, and what you hear. I know. Oh, I'm sorry.
Damn it, man.
I know.
I'm gonna use the radio voice. Yeah, hi, I'm Tony, also known as Tony T. I run a small little outfit called Phantom Hex. I also do a podcast called Mad Bro. I just got into Python, and I'm doing the Python thing over at Code Google. And yeah, that's pretty much me in a nutshell.
Sweet. Thanks for coming, man. Appreciate it. Okay, so I want to first talk about what machine learning is not. And I love these headlines because they really make me laugh. And no, the human race will not be terminated. That's not what machine learning is. No, it's not going to end the middle class. No, there's going to be a whole new industry of jobs that are going to come up all around training algorithms. No, I don't think so. It's really funny. And also, on a side note, I love Elon Musk. But I don't know if he's actually writing the algorithms. Because I'll show you soon, but AI and machine learning is just math with data. That's all it is. It's not the Terminator. It's not uncontrollable. It's just guys using math to work on data. So just keep that in mind. It's really exciting stuff to get into. Once you understand the power, it's awesome. But your Python project is not going to grow legs and walk off. So that being said, I told you what it's not. What is it really? Just to kind of illustrate it, humans, animals, we all learn from the experiences we have, whether that be in the wild as nomads collecting food, danger. We figure out ways to get wisdom from our experiences, and that's a knowledge base. Computer programs are chips of silicon that is very explicit and have to be kind of handwritten what it does. So turn left 30 degrees, walk 7 paces. It's very super explicit. To kind of merge those two things, neuroscientists and AI researchers are basically trying to use machine learning to just learn from data. It attempts to mimic the way that humans accumulate knowledge, but it's completely different. And it'll never be the same as that. Potentially, I mean, we can talk about neural networks later, but so the point of machine learning is to learn from data. So some examples, if you see the black line, that is a stock ticker of an actual company, and I won't go over all of these, but the colors represent different type of algorithms used to try and use historical data to replicate and or predict what the stock's going to do. So it's not exact, but you're starting to see some similarities here. So that's one use. Another field of study in machine learning and AI is something called sentiment analysis. is when you are flagging or you're trying to pick apart a series of words and trying to associate some type of subjective context or sentiment value. So this is very commonly used with reading tweets and trying to figure out, is it a happy tweet or a sad or a mad tweet? So positive versus negative tweets. And actually, hopefully we'll have a blog post out next week how I use sentiment analysis to predict how well a stock is going to do. Really cool stuff. I just got to finish the code, but the article's done, and I'll see if I can share it or something. Really cool little fun project I'm working on. And then I have to do a shameless thing, my former employer. Or you can fill out 5 questions, and it spits out 5 discrete measurement values for you at Generation Tux. So worked at Generation Tux with Colin and B-Banks, and just had that in there. So it was a lot of fun to do, and I think this was the catalyst where you start to see, like, it's not just for self-driving cars or stocks. You could find ways to apply this to any industry. So this is a very simple and kind of sums up a process in machine learning. And in this example, this is going to be what's called supervised machine learning. And what you have is you have a series of data points, and you have associated some type of value or mapping to it. So the most common data set is the iris data set. If you guys are familiar, we'll go over it a little bit later, but basically trying to say what species of flower it is based upon different lengths of the petal and things like that. So as long as you have those labels, then you are going to take a machine learning algorithm, and then you're going to say, okay, I've created a model that's based on this data. So now when I feed it brand new data that it hasn't seen before, it's going to use that to essentially make a new prediction. So just kind of the core high-level basics, just to get it out there. That's machine learning, deep learning, supervised learning. So that, I need to make sure that's in the Git repo, because this is not mine. Pleep is not mine, but I found it and I thought it was cool. So there are 4 kind of high-level parts to a machine learning project. You got to take your data and make it to where you can compute it in a mathematical way. So you also need to get rid of outliers, empty data records. There's a lot of data wrangling that goes on just to get ready for the project. Colin and Brandon will attest that when you actually do a machine learning project in a company, 75 to 85% of all the work you do is the first one, just the data pre-processing. Figuring out what data can you use, how are you gathering it, are you confident in the data? We could do several topics on just this first one alone. It's a very huge and deep field just for data pre-processing. Tonight, it will be very quick. The second one is what most people know when they think of machine learning, and that is applying an algorithm, figuring out what's wrong with it, changing the values, and kind of tweaking an algorithm to actually, this is your mathematical model for your data. Evaluation, that is looking at the accuracy, that is looking at potentially if you're doing something called underfitting or overfitting, and I'll talk about that a little bit later. And then this doesn't exactly represent what I think it is. I think prediction should be more of deployment. But essentially what I mean by prediction is, now that you have a good model, you're confident in it, now it's time to put it out in the wild, whether it's on an Android or iOS app, or it's on an API server, put it out there so you can actually start feeding it new data. So to help me remember these 4 high-level things, I just think of PLELP, the acronym, and then to help me remember, I don't know if it'll help you guys, maybe you should come up with your own, but for me, I use Please Let Evan Pee, and I don't know, that just sticks with me, so I won't forget. So maybe because it's just so silly that I know that I won't Please, guys, please let Evan be. All right, so let's kind of dig in a little bit into pre-processing. So I have a what's called a head, or just a few records of this iris flower data set. And the first 4 columns are basically the data, or the raw data. And then the last one, the actual species, is the label. So when you think about it as a math equation, basically you have x1, x2, x3, and x4, and then you have y. And that's your label. So whatever you think about in your data set, the prediction, when you feed it new data, you want it to give you the y. And then once you process it correctly, it becomes your training set. Your test set we'll talk about a little bit later, but then that helps you figure out if your algorithm has memorized the data set to a T, or if it's just too general that it's not actually going to be that accurate. And I'll talk a little bit more about that. So step 1. Step 2 is the actual hard work. So the first time when you run a machine learning algorithm, it doesn't know anything yet. It has no context. You're just feeding it data. It has no clue what's going on. So mathematically, these are weights or biases that are pretty much either 0 or 0.5 or random numbers. You just need some type of basis to get started. And the next step is, once you actually do that calculation, you can now look and say, okay, the first time I ran it, calculate how bad was that compared to the labeled previous data. How awful was it the first time around? So that's what's called an error function, and I'll talk a little bit about that. Or another way you can put it is like, what weights are to blame for why this isn't accurate at all the first time around? Then once you have a good basis starting point, then the next step is, okay, is there a way we can find out another step to get more accurate, or to minimize our error, or to minimize how bad it is? So there's a mathematical way that you can figure out how should I change the weights? In what direction, up or down, should I change the weights? And then you just run them again. And then you'll say, okay, what's the new error? How bad is it now? You say, okay, it's this bad, all right, let's change the weights again. And then you're doing this continuous cycle, and it's called a mathematical optimization, where that is the core of the training. That is how you're taking training data that you've given it, and then figuring out what is a mathematical model that can effectively predict new stuff.
Are you doing that manually or programmatically?
So I'll talk a little about that with TensorFlow and Keras. It's now extremely easy to do. You can now implement and do these machine learning projects without even knowing there's 3 steps. Well, more or less. It's gotten a lot better the past few years. But under the hood, especially when you see results and you need to know how to tweak it, it's kind of good to know these steps that are going on. So, any questions on that? That's kind of a lot right there. Okay, cool. So evaluation. We have the same data points, but we have 2 different machine learning models. The lines or the slopes are basically the models that have been trained. Does anyone want to take a guess which one they think is better? Except
Here's one.
why the one on the left?
Because the note was he memorized all the data.
Yes, exactly. So in this model, it pretty much to a T just used the data set that was given and just mapped it exactly. So let's see. Yeah, so if you look at the one on the right, yeah, it's gotten every single data point, but look at the error function. It's a lot bigger error than that same data point on the left one. So a huge thing with training these machine learning models is figuring out, have you underfitted or generalized too much that it's not accurate at new data, or you've trained it so well that you give it something new and it's just going to be way off because it's only gotten super good at the data you've given.